हेलो फ्रेंड्स। आज के इस ट्यूटोरियल में हम लोग देखेंगे मेनली अबाउट ट्रांसफॉर्मेशंस, नैरो एंड वाइड ट्रांसफॉर्मेशन इन स्पार्क। बट बिफोर दैट देयर आर सम फ्यू टॉपिक्स, इंपॉर्टेंट टॉपिक्स जो आपको आनी चाहिए, राइट? सो यू शुड नो डाटा फ्रेम क्या होता है। विल क्विकली टच अपॉन दीज टॉपिक्स, ओके। पार्टीशंस क्या होते हैं डाटा फ्रेम में, एंड थोड़े बेनिफिट्स एंड ऑपरेशंस which are available in Spark data frame. उसके बाद we'll go through the transformations, wide and the narrow transformation. Right? देखते हैं, चलो। So डाटा फ्रेम क्या होता है? डाटा फ्रेम इज अ डिस्ट्रीब्यूटेड डाटा स्ट्रक्चर, राइट? जिसका मतलब है आपका डाटा जो होता है दैट इज नॉट स्टोर्ड एट अ सिंगल प्लेस, इट इज डिस्ट्रीब्यूटेड अक्रॉस द स्टोरेज. That's why it's called distributed data structure, है ना? And it takes the help of Spark to implement distributed processing. Spark की मदद से we are able to manipulate this data, right? So we have a data frame reader API that helps you to read this CSV file, right? So let's say मेरा data is in the CSV file format. तो मैं Spark data frame reader API में there's a method called read CSV, right? So using spark.read.csv, I'm able to read data. Now, आपका जो distributed file system है, it can be either HDFS, it can also be Amazon S3 storage, right? S3 bucket. It can be your ADLS, Azure Data Lake Storage Gen 2, right? So this storage can be anything, any kind of any sort of distributed storage. The main thing to notice is, let's say आपका एक CSV file है, right? It's a huge CSV file. Now, my storage cluster is a 10 node storage cluster, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So let's assume we have a 10 node storage cluster, ठीक है? एंड जब मैं अपना फाइल सेव करूंगा ऑन दिस पर्टिकुलर क्लस्टर, मेरा फाइल it might get broken into 100 smaller partitions. Each of these cluster nodes can have 10 partitions each. You get my point, right? So there's a CSV file, right? And which I'm trying to store on my HDFS or on my S3 storage, right? So my file, it might be broken into 100 smaller partitions, right? And each of my cluster node, right, may contain n number of partitions, right? Altogether, it will be 100 partitions. So the number of partitions, all of those things can be configured in some storage system, right? But that's out of scope now. बट आपको इतना ही समझना है कि जो भी मेरा डाटा है मेरे स्टोरेज में इट विल बी डिस्ट्रीब्यूटेड एंड स्टोर्ड, राइट? एंड ईच ऑफ दी स्मॉलर चंक ऑफ फाइल इज नोन एज अ पार्टीशन, ओके? नाउ एट अ स्पार्क लेवल लेट्स ट्राई एंड अंडरस्टैंड व्हाट्स हैपनिंग. सो दिस इज माय स्टोरेज जो ऊपर देखा हमने, HDFS और S3 और ADLS, राइट? एंड देन आई हैव माय स्पार्क सेशन, स्पार्क ड्राइवर, राइट? अभी whenever I'm doing a spark.read.csv, what happens? Let's see. ठीक है? So मान लो कि मैंने कॉन्फ़िगर किया है to start 5 executors, right? So each of these green box is an executor, 1, 2, 3, 4, and 5. Okay, and for each of my executor, I have 5 CPU cores. Okay, so this is the first core. All these red dots represent your cores. Okay, 1, 2, 3, 4, 5. So I have 5 executors, right? And each executor has around 5 CPU cores. ठीक है? अब मेरा जो डाटा है, right? So what my driver will do is driver will distribute the work to these executors. Get it? So मान लो इत- ऐसे दो set of files from two of my storage cluster nodes goes to my first executor. Okay, next three set maybe goes to my second one. Okay, like that your driver will distribute the work to these executors. Get it? Now, each of your cores may or may not have one or more number of partitions. So, मान लो इसमें 10 partition file थे, right? So my driver will distribute these files across the cores, right? So if you see here, you can see multiple partitions. यहाँ पे एक partition, यहाँ पे another partition, right? So this is internally handled by my driver. ठीक है? So so the basic idea is driver is going to assign some of my data frame partitions to each of the JVM core, right? So that is the whole idea. Hmm. Now you're ready with a distributed data frame setup, right? You get the point, right? How your data is distributed, right? And how your executors get the data. So this is how it works in the backend. Okay, guys, one small request. आपने अगर चैनल को सब्सक्राइब नहीं किया तो प्लीज कर लें and I'll highly recommend you to do so because मेरे लिए that's a huge motivation to keep creating such videos, right? Great, thank you. So back to the lecture. Now we'll see some of the Spark benefits, right? So Spark क्या करता है? It hides out all the complexities of distributed processing. So जितना भी मैंने explain किया, right? So Spark will simply hide out all of these things. So आप अगर एक CSV read करते हो using Spark, and if you do some kind of show or display on your console, you'll be able to see the entire data frame, right? So आपको ये नहीं पता रहेगा कितने पार्टीशंस हैं, कौन से कोर में कितने पार्टीशन गए हैं फाइल्स के. All of these things are abstracted, right? So these are some of the benefits, hiding out all the complexities of distributed processing, right? And we can simply work with data frame as we work with a plain non-distributed data structure. So एक बार मेरा data frame read हो गया, I store it into some df, df1. उसके बाद I can carry out all my operations. Now, Spark data frames are immutable data structures. You can give instructions to your driver about what do you want to do, right? And let the driver decide how to achieve it with the help of the executors. Okay? Now, these instructions are called transformations. Okay? Right? You get it now? तो यहाँ पे अगर देखोगे आप राइट साइड में I've written a small block of code. ठीक है? Survey df is my df to which I have read a CSV file, right? And now what I'm trying to do is on survey df, I'm applying some kind of filter where age is less than 40. So अभी अगर आप यहाँ पे देखोगे मैंने बोला it's a Spark DFs are immutable data structures. So अभी आपका survey DF is not at all disturbed. This data is getting stored into your filtered DF. Okay. So this is one transformation that I've done. Now in the next step, my filtered DF पे I'm doing a select, right? I'm selecting these columns. And then I'm creating another DF data frame called selected DF. तो मैंने क्या किया है? I cannot modify my filtered DF. I am rather creating a new data frame, है ना? Similarly, मैंने उसके बाद एक grouping किया है. Selected DF को उठा के group by country कर दिया, ठीक है? तो that comes to your grouped DF. And finally, I'm taking out a count. Okay. So these are all transformations that we are doing, right? Some kind of operation that we are doing, है ना? And these are called transformations. अभी transformation होते हैं दो type के, narrow और wide. Before going into that, there is something called actions, right? Actions are commands that trigger the computation of a result from a data set. तो मैंने इतने operations कर लिए हैं. Now I'm doing a show, right? To read, write, collect, and show. These are some of the examples of actions. So unless I'm doing a show, the evaluation will not happen, and that's called as a lazy evaluation, right? So transformations are lazy, but actions are evaluated immediately. That means Spark internally जितने भी मैंने transformations किए हैं इन पे actions नहीं लेगा. There won't be any Spark job that is going to get created. But as soon as I do a dot show, the actions are evaluated immediately. ठीक है? So that's one. So you need to understand what is lazy evaluation in Spark. Okay. But this is the main topic of today's discussion. What is narrow and wide transformation, right? अगर आप ChatGPT देखोगे, quickly if I show you here, narrow transformation देखो. Narrow transformation involves operations where each input element of data can be used to produce an output element independently of others. ठीक है? Doesn't make sense, right? Same way, wide transformation का भी एक definition है. Okay? We'll understand क्या है ये and then we'll go back and read the definitions again. Right? अभी to understand the narrow transformation, let's look at this table. ठीक है? We have a table where we have age, gender, country, and state, right? And I am applying some kind of filter where age is less than 40. This is my filter. Okay, so this record will be filtered out, 44, and 45 will be filtered out, right? So this is the output that I get, right? Now let's see. So this is in the case of a single partition system, right? So मेरा ये जो table है, that's falling into a single partition, right? Now let's say the same table is distributed across two partitions, 1 and 2. Okay. Now 37, 44, 32, and 31. This I've kept it in the first partition, if you see, right? The remaining four records have been put into the दूसरे वाले partition में, ठीक है? Now अगर मैं इस पे where condition लगाता, right? So single table पे if I put a where condition, this is my expectation, right? 44 will be gone and 45 will be gone, right? So now if it is a partition, so this is first partition, this is second partition. अब देखो इस पे मैंने I have done a where age equal to where age less than 40. I'm getting this as the output, and from my second partition I'm getting this as the output. I am combining both of these outputs, right? And whatever I'm getting here is my desired output, right? So this is a example of a narrow transformation, right? ठीक है तो I have captured the definition here. If you see, a transformation that can be performed on a single partition and still produce an overall valid result is a narrow dependency, right? So यहाँ पे आपने partition पे some kind of operation किया. I've done a where operation on my partition and I've got a output, right? Similarly, यहाँ पे भी I've done a where operation. I've got an output, and combining these output doesn't give me a absurd result. ठीक है कोई गलत result नहीं आ रहा है मेरे को. तो this is a narrow transformation. Now let's look at Y transformation. ठीक है same table, two partitions, number one, number two. So अगर मैं इस पे count निकालता group by country, and if I'm taking out a count, if let's say if this was a single partition, right? There's no partitioning. There's a single table on which I'm doing a group by on country and taking out the count. I will get United States 1, 2, United Kingdoms 1, 2, Canada 2. So this is my output here, right? This is the desired output. Now, since this is a distributed system, my data is partitioned, right? अभी दो partitions हैं. On each of the partition, I'm doing a group by on the country, right? So when I do a group by on the country, I get three countries here, right? And then I'm doing a count. So for United States, I get count as 1, UK I get count as 1, Canada 1. Same way here also, if I do a group by on country, I get three countries, and then when I take a count, मेरे पास again I'm getting United States के लिए एक, UK के लिए एक, Canada के लिए 1. I combine these two results. See what's happening? United States 1, I have one record. United States 1, I have another record, right? Same way UK 1, UK 1, Canada 1, Canada 1. So this is not equal to the desired output. So this is where you have the problem. So this is a scenario where you see wide transformation, right? So group by is a wide transformation, right? Whereas where condition which you're doing is a narrow transformation, because on any partition, if you do a transformation where, right, the output is still the desired one, right? So irrespective of the number of partitions, my output is correct, है ना? जो मेरे को output चाहिए वही मेरे को मिल रहा है. So that becomes your narrow transformation. एंड वाइड ट्रांसफॉर्मेशन, फॉर एग्जांपल ग्रुप बाई में क्या होता है, आप अगर एक पार्टीशन में सम काइंड ऑफ आप ग्रुप बाई करके इफ यू आर टेकिंग अ काउंट, राइट, and on a different partition if you're taking account, at the end all these partitions combine to form the same data frame, right? And if you take out a group by count and then if you compare the output, right, this is not the desired result. So this is a wide transformation, right? So now इसके लिए क्या करें? How can we fix it, right? So we can do that using something called repartitioning of the group data. What does it mean? Simple. आपको जितने भी पार्टीशंस आ रहे हैं यहाँ पे इस स्टेज पे, राइट, जितने भी पार्टीशंस आ रहे हैं इनको कंबाइन कर दो. Combine this, and then you will carry out something called as shuffle, sort, or exchange, right? So this process is called shuffling, right? So you are essentially going to shuffle the data, right? And then you are going to distribute the data into different partitions, right? So if you see here, all the United States and Canada is in one partition, and UK is in a different partition. Now, if you do a group by on this, I mean, now if you do a count on this, right, you will get the desired result. United States, Canada 2, 2. From here, United Kingdom 2. I hope you get the point, right? So basically, आपका ये जो shuffle हो रहा है, right? That is the main thing which happens in a wide transformation. And who will take care of this shuffling, right? आप सोच रहे होंगे आपको ये shuffling जाके करना पड़ेगा, नहीं. Okay, all this will be managed internally, right? The shuffle, sort, जो भी हो रहा है ये सब internally manage होगा, and we do not have to do anything for shuffle or sort. Spark will internally manage it, right? Okay, I hope you get how the narrow transformation is working and how the wide transformation is working, है ना? Wide transformation के case में there is a shuffle, sort, exchange that is happening, and Spark will internally manage this, right? Now let's quickly see the definition again. Simple words में transformation that can be performed on a single partition, right? Narrow transformation, right? एक ही partition में you are doing the transformation and still produce an overall valid result. आपको जो भी finally result आ रहा है यहाँ पे, right? That is a valid result, है ना? So this is a narrow transformation. In case of a wide transformation, a transformation that requires data from other partitions to produce correct result. तो मैं जब यहाँ पे I was carrying out the operation, this is not giving me correct result because this also requires data from this partition, right? So this will not give me a proper result. And in which case there is a shuffle that happens internally which is taken care by Spark. Okay, so these are the definitions. Finally, हम लोग यहाँ पे एक बार चैट जीपीटी का भी देख लेते हैं. Narrow transformation involves operation where each input element, each partition of data can be used to produce an output element independent of others. Basically क्या बोल रहा है? Independent of दूसरे partition, you can get the output, right? That is your narrow transformation map, filter, flat map, where everything is narrow transformation, right? And wide transformation क्या है? Are those where the operation needs to combine data across multiple partitions, right? Multiple partitions से data combine करना होता है, and which might result in big data being shuffled across the cluster, है ना? And this is done by Spark. ठीक है? There is group by, there is reduce by key, join, sort by. So these are all the examples of wide transformation, right? So that was all about the narrow and wide transformation in Spark. I hope आपको ये वीडियो पसंद आया हो. Please सब्सक्राइब कीजिएगा मेरे चैनल को. And if you want this PDF, this Excel notes to be shared, आप comment box में अपना email ID छोड़ दीजिए. I will definitely share this Excel file with you. Okay. Thank you. Please leave a like and do subscribe.